A class has 9 undergraduate and 11 graduate students. A group of 5 is chosen at random. What is the probability that the group has 1 undergraduate and 4 graduate students? So the group having this many of each student, that's going to be my event E. And so the first thing I want to do is I want to figure out the number of ways that this event can happen, because I'm trying to figure out the probability of E, which is going to be n of E over n of s. I'm writing it down here because that's where I'm going to continue with it. I'm going to first figure out what n of E is, though. So I need 1 undergraduate student. There are 9 undergraduate students, and I want 1 of them to be chosen. This is a group, so we're starting from a larger group. We have 9 people here, and we're picking 1 of them. And even when we're talking about 4 people here, there's no real implication of ordering these people. So I would say that this is going to be combinations. So we're dealing with a combination here. We have a larger group from which we're picking a smaller subsample and we're not arranging them. So they're going to be, from the 9 undergraduates, we're picking 1 undergraduate, so this is going to be 9 choose 1. And for each of the ways we pick the undergraduate, there are 11 choose 4 ways to pick the graduate students. And so I'm going to use the multiplication principle here and say that, well, the product of these is going to give us the total number of ways that I could pick 1 undergraduate and 4 graduate students. N of S, my sample space, I don't care about whether or not they're graduate students. I just care about the fact that there's 20 students total, and I'm picking a group of 5. Because this is, this is in general what we tend to do with our sample spaces here. So let's see, 9 choose 1 times 11 choose 4. I might actually figure those numbers out. 9 choose 1 is 9. That one's easy enough because it's choosing 1. But 11 choose 4 I'll actually enter into my calculator. That's 330. So 9 times that is 2970. And 20 choose 5, let's figure that out as well. 20 NCR 5 is 15,504. So this ends up giving us 2970 over 15,504. And you could reduce that, I'm sure, but I don't really care. All right, what is the probability that the committee is entirely graduate students? So this would be 0 undergraduate, and thus 5 graduate students. So our E is now going to be a little bit different. Maybe I should call it F so you don't get it confused with the E I have up there. This is F. And so this is going to be from the 9 undergraduate students, we'll choose 0. From the 11 graduate students, we'll choose 5. And if S is still the same number. Now, whenever we're doing something choose 0, this is just 1. If we have 9 undergraduate students, the number of ways we can choose 0 of them is we just don't choose any of them. So the only number I'm caring about here is 11 choose 5. 11 choose 5 gives us 462. So the probability of F, N of S, I should probably state this. This is that 15,504 again. So the probability of F is going to be that 462 over the 15,504, whatever that reduces to. How many such groups have at least 1 graduate member? So the fact that I'm saying at least 1 graduate member does make this problem a little bit more complicated, because now I need to think about, okay, if I'm counting up the number of graduate students, that's what I'm going to count here. So we could have 0, 1, 2, 3, 4, or 5. If we're talking about having at least 1 graduate student, that means we're talking about the probability of being somewhere within here. So what I'm going to do is I'm going to figure out the probability of 0 grad students. That's this one right here. And I'm going to use the complement rule to find this bigger part right here. This stuff right here is going to be 1 minus the probability of 0 graduate students. So, 0 graduate students, I've used E, F, let's call this, G is a little weird, but whatever, I'll call it G. The probability, or n of g rather, the number of ways I can have 0 graduate students. Well, from the 9 undergrads, we would have to choose all 5 of them, and from the 11 graduate students, we'd have to choose 0. Again, n of s is the same, it's still 15,504, and so the probability of g is going to be, I guess I need to figure out what 9 choose 5 is. 9 choose 5 is 126. Thus, 1 minus the probability of 0, yeah, 1 minus that probability. 15504 minus 126 is 15378 over 15504. All I'm doing here, the reason I did that subtraction is I'm counting this 1 as 15504 over 15504 minus 126 over 15504. So this right here, that's how I did that subtraction, or wait, 126, not 166. Like that. Yeah. So that would be the probability of getting at least 1 graduate student in this committee.